Hi, the focus of this second video is a synthetic division of polynomials of degree 5. I'll be using the C language for this tutorial. A link in the description will take you directly to the work page. This is a work page, a wikibook. You must first download the hash file. You find here the hash file. You can then download the first example, a C file. This is the first example. I download the first example for this video. I put it into my editor. I verify if I have the hash file. Yes, I have the hash file, and this is the C file. I save the file. Synthetic division. The long division of polynomials can involve many steps and be quite cumbersome. Synthetic division is a shortcut that can be used when the divisor is a binomial in the form of x minus k, where k is a real number. In synthetic division, only the coefficients of the polynomial are used in the division process. Can you explain how to divide 3x power 5 minus 38 power x power 3 plus 5x power 2 minus 1 divided by x minus 1? Using the synthetic division and the C language. For this example, k equal 1. This gives x minus k equal x minus 1. Here, x minus 1. Remark: some coefficients are 0 in these polynomials. This when x with x power 4, with x power 4, and with x power 1. To display the 0 coefficient, we must rewrite the polynomial in this manner. To display the 0 coefficients, you must rewrite the polynomial in this manner. In this manner, you have the 0 here, and you have the 0 here. The coefficients of the polynomial are displayed in this array. The coefficients of the polynomial are displayed in this array. Plus 3, 0, 0, minus 38, plus 5, 0, 0, minus 1. Now I try this example. Hello. I must verify that I have the good array. Yes, this is a good array. Okay. I want to use k equal 1. K equal 1. K equal 1. And this is a polynomial of degree 5. This is a polynomial of degree 5. I try this example. This is the result. Okay. This is the result of my work. This is a polynomials. This is a polynomial. This is the algorithm of the synthetic division. In the first line, I copy the coefficients of the polynomial, plus 3, the 0, minus 38, plus 5, 0, and minus 1. On the first line, I copy the coefficients of the polynomial. I left the second line empty. I copy in the first line the first coefficient, plus 3. Now I go to make the algorithm. Alors, I multiply plus 3 by plus 1, this gives plus 3. I add 0 plus 3, this gives 3, plus 3. I multiply plus 3 plus 1, this gives plus 3. I add minus 38 plus 3, this gives minus 35. I multiply minus 35 by 1, this gives minus 35. Now plus 5 plus minus 35, this gives 30. I multiply minus 30 by 1, this gives minus 30. I add 0 plus minus 30, this gives minus 30. Now I multiply minus 30 by 1, this gives minus 30. Now I add minus 30 plus 30, this gives minus 31. This is the result of the algorithm. This is the result of the algorithm of the synthetic division. You can write this result in this manner. The first coefficient become here. The second coefficient came here. The third coefficient came here. The fourth coefficient came here. The third 1, 2, 3, 4, 5. The fifth coefficient came here. This is the remainder. The remainder you can write in this manner. Minus 31 divided by x minus 1. X minus 1 is this value. Okay? Alors, the remainder is also P of k. If k is this value, x minus k is this value, the remainder is the computation of P of k. In this example, k equal 1. Also, P of 1 is minus 31. Is minus 31. Okay. So this is a simple example. Now my goal is to demonstrate how to introduce a new polynomials in the C file. My goal is to demonstrate how to introduce a new polynomials into the C file. This is a new polynomials. It is a polynomials of degree 5. All the values of the coefficient have 0. All the coefficients are 0 without soft. The first and the last. Sorry. and I have choose to K3. Okay. Alors, and the coefficient of the polynomial and the coefficients of the polynomials are displayed in this array. 1 for this value, 0, 0, 0, 0, and the constant value is minus 243. Alors, I must introduce this new polynomial in my C file. Alors, the degree of this polynomial is 5. The degree of the polynomial is 5. I have chosen that k equal 3. I write k equal 3, and the coefficient of the polynomial are displayed in this array. The coefficient of the polynomials are displayed in this array. Alors, I copy this array into my C file. Alors, this is the old array, or perhaps, and this is the new. I erase the old array, and now I can try this new example. Alors, this is a new polynomial. This is the algorithm of the synthetic division, and this is the result. You can see here you have 0. The remainder is 0. This says that the plus 3 is a root of the polynomial. X is a plus 3 is a root of this polynomial. I can copy this polynomial. Oh, sorry. Perhaps I can compute the algorithm. Alors, the first thing, I must copy all the coefficients of the polynomial in the algorithm. The first value is 1, then 0, 0, 0, 0. All the coefficients are 0. The last coefficient is a constant value, is minus 243. Now, I left this line, the second line, empty. I copy the first coefficient in the third line, and now I compute the algorithm. Plus 1 multiplied by plus 3 is plus 3. 0 plus 3 plus 3. I multiply plus 3 multiply by plus 3. This gives 9. 9. I add 0 plus 9. This gives 9. I multiply plus 9 by 3. This gives 27. I add 0 plus 27. This gives 27. Okay. Now I multiply 27 by 3. This gives 81. I add 0 plus 81. This gives 81. Now I multiply 81 by 3. This gives 243. I add minus 243. plus 243, this gives 0. Okay. The remainder is 0. This explain. This gives the remainder is 0. Also 3 is a remainder of these polynomials. You can rewrite the result of the synthetic division in this way. Alors you write here plus 3 plus 9 plus 27 plus 81, and the remainder is 0. Also this value is 0. I copy this value. I copy this value. I copy this value here. This value is 0, and the result of this the algorithm of the synthetic division say to us that plus 3 is the root of this polynomial. Alors, I can write in this way x minus 3, and I can factorize the polynomial in this manner. Okay, I can try to verify this. Alors, I copy this polynomial. I use Mathematica. I copy the polynomial into I copy the polynomial into Mathematica. This gives the result, and now you have I don't want to, I want to copy plain text. Okay. I copy the result. Yeah, this is the result in Mathematica. Okay, you find the same result. Is not right in the same manner. Yes, but this is the result of Mathematica. Alors, 21, 80, 81, 27, 9, 3, and 1. It's not right in the same manner, but it is the same result. Okay. Alors, my goal is to demonstrate how to introduce a new polynomial in the C file. This is a new polynomial that I have introduced with k, and this is the array for this polynomial. I try to introduce a new polynomial. Our goal for this example is to modify the degree of a new polynomial. Now we not only introduce a new polynomial, but the polynomial have a different degree. This time the degree of this polynomial is 3. Okay. Alors, the new polynomials is of degree C. e for degree 3. See, also I write 3. For k, I use k equal 1, k equal 1, and this is the new array for this polynomial. This is the new array of this for this polynomial. 1 here, 0, coefficient 0, and -1 for the last coefficient, the constant value. I copy this new array into my C file. I erase the old array, and I can try the new example. I have several arrays, donc I compile the new array, and this is the new example. I work with these new polynomials. This is the algorithm of the synthetic division. The first thing, in the first line, I copy the coefficients of the polynomial. 1, 0, 0, and -1. Now I left the second line empty, and then I copy the first coefficient in the first line. Now I multiply the first coefficient by 1, this gives 1. I add 0 plus 1 equals 0. I multiply this coefficient. I multiply 1 by 1, this gives 1. I add 0 plus 1, this gives 1. Now I multiply 1 by 1, this gives 1. Now I add -1 plus 1 equals 0. The result gives this line. The synthetic division gives this line. The remainder is 0. Also 1, k is a root, 1 or k is a root of this polynomial. Okay. Alors, the synthetic division indicates that the result is, this is the result of the synthetic division, and you can write in this manner. Alors, x squared x plus 1, the constant value, and the remainder is 0. The remainder is 0. I copy this value. This value is 0. I erase this value. The synthetic division explains that plus 1 is a root. I can write in this way, x minus 1. I can factorize this polynomial in this way. Why? Because the synthetic division explains that the value 1 is a root of this polynomial. Okay. I can copy this polynomial into Mathematica to verify. Go. This is the result of Mathematica. I can write P of x. This is the result of Mathematica. It's not in the. It is not right in the same manner. -1 can be here. Alors, x minus 1, x minus 1, x power 2, x power 2, x plus 1 plus 1. Okay. I close now. Alors, I would like to make a second video on the synthetic division. I would like to make a second video on the synthetic division to demonstrate to you how to introduce a new polynomial in the C file, a polynomial of the same degree in the first example. In the second example, a polynomial of a different degree. And this is the polynomial of degree 3. Now I stop the video because I am not able to continue. Thank you.